Leute, herzlich willkommen zurück auf Kitty Tech. Wir schauen Electroboom Videos an. Eine Halbvolt gepisste direkt.
Hi, do you have a wall adapter or power supply that doesn't output right? It turns on and off or can't maintain its voltage? It's likely the damn electrolytic capacitor in it. If you have watched my videos, you know electrolytic capacitors can blow with a Oh, they have to be connected to a circuit to blow up, but they don't always blow up. I want to see what happens to them when they half break. Let's half break one. Okay, I have a tiny electrolytic capacitor and I'll half break it in an accelerated fashion by connecting 120 volt AC across it. Don't try this experiment. These capacitors typically half break over a lifetime of usage, but I don't have that kind of time, so I'll over voltage it until it half breaks. Just a quick touch. Well, this is a very familiar mode of failure around this neighborhood, where excess overload results in capacitor elimination. This is a total failure. When I say half failure, I mean the capacitor still capacits, but it is capaciting at half its capacity. Capacit is not a verb. It's like when you add or to a verb. Inductor inducts, collector collects, mentor ments. Ment is not a word. When I hired you as my writer, I thought you could English. I can English just fine! Anyway, a halved capacitor still works, but halvely. Let me draw this for you. A capacitor is made of two conductor plates side by side, separated by a non-conductive isolating layer called a dielectric, and charges are stored on its plates. The wirings inside a capacitor have their own resistances, we show as a very small equivalent series resistance or ESR. Also, even the best dielectrics can leak very little current that we can show as a super large resistance. We always ignore it's so large, like giga-ohms. And then we have polarized capacitors like electrolytics that the dielectric is such that it acts like sort of a diode. I explained all these in my video about capacitors, but any part of a capacitor can degrade, causing a less capaciting capacitor. It's not a word! I have a brand new 60 volt 40 amp power supply and my capacitor is rated for 16 volts, but I place it in reverse polarity, and if I increase the voltage, at some point it starts conducting current and the capacitor will slowly heat up. You see? Oh, there you go. It's starting to conduct. It's almost 1 watt through the capacitor. Oh, I didn't even see it bulging. I guess it's like a pressure cooker. The dielectric gel in these electrolytic capacitors boils and the pressure builds up until it blows up. I just want to half break a capacitor. I guess I have to let it cook slowly, so I just give it enough voltage for a little bit of current so that it doesn't blow right away, and I just put it on the side and let it get damaged over time. Now, while the cap is cooking, did you see Elon Musk's latest announcement that a person with Neuralink's brain implant can move a computer mouse with their thoughts? Is that good or bad? To understand it better, I used articles from my sponsor Ground News. This platform was created by a former NASA engineer. They collect news articles on any topic from all around the world, so you can compare coverage in a scientific, data-driven way to get the full picture. Check them out at ground.news/electroboom. On this subject, they have over 150 articles, so we can see a spectrum of reactions. One calls it Nobel Prize worthy, while the other worries about the risks of having a chip in the brain. Not only can you get the information from all sources, but also Ground News reports on where they stand on the political spectrum. This makes Ground News such a valuable service because knowing the existing biases in articles makes it easier to get to the truth and avoid censorship and misinformation, which is why I'm a fan of Ground News. And there you can also follow your interest for the latest updates. I use the Vantage subscription for unlimited access, which you can get at 40% off using my link, if it wasn't cheap enough already. Or try their starter plan for just $1 this month and keep yourself well informed and support a team who's working to make the media more transparent. It should be well cooked. Oh, shit! You know, the issue with tiny capacitors is they don't have pressure release mechanisms, but the and support a team who's working to make the media more transparent. It should be well cooked. Oh, shit! You know, the issue with tiny capacitors is they don't have pressure release mechanisms, but the bigger power capacitors have it, because the explosion can be catastrophic. So they have, for example, these tiny grooves on the top plate. This is a healthy 2200 microfarad capacitor with an ESR of around 0.1 ohms, and the parallel resistance is over 6 mega ohms. So when I overload the capacitor and it bulges, those tiny grooves on the top break open, allowing the release of the pressurized gases, and this will save the Woohoo. Well, stop it. I guess this is a much smaller explosion compared to what could be. I'm pretty sure this is a half-blown capacitor now. Measuring the parallel resistance. Oh, it's well over 11 mega ohm now. Well, the good thing is that the plates are not shorted, so it should still be able to capacitate. The capacitance now is only around 420 microfarad. Dropped way down from the original 2200 microfarad. And the ESR now is 1.1 ohms, over 10 times what it was before. I mean, it takes a lot of talent to be able to half break a capacitor after how many minutes now? So it is still a 420 microfarad capacitor, but it is capacitating much less than before. Still not a ward! The lower capacitance and higher ESR is a problem for almost every power supply where the circuit takes the 420 microfarad capacitor, but it is capacitating much less than before. Still not a ward! The lower capacitance and higher ESR is a problem for almost every power supply where the circuit takes the input energy and pulses the energy into the output. And the capacitor's duty is to absorb those pulses and create a constant output, like a switching inverter or a full bridge rectifier. Here I have a full bridge rectifier with its output hooked to a capacitor and powered from an auto transformer, so we can provide a safe lower AC voltage. We just have to always reduce your supply's voltage before hooking your circuit up to it. So here is the rectified DC voltage with a 100 microfarad capacitor. If I connect a resistor to it as a load, we see it is rippled because during the off periods of the diodes, the capacitor discharges into the resistor trying to keep the voltage up until the next wave of input charges it back up. But if I connect a smaller 10 microfarad capacitor to my circuit, let alone the higher ESR, with the same load, the capacitor discharges so far it can reset circuits constantly. So anytime you see a bulged capacitor, you should replace it with preferably better parameters so they won't degrade the same. Well, I did have a problem with this wall adapter here, which supplies to all my security cameras, and all my cameras were turning on and off. I cut it open and lo and behold, it was a bulged capacitor. I replaced the capacitor with a higher rating capacitor and it's been working since. Now that we know all this, let's repair a broken power adapter together. This also doesn't output voltage. Looking at the circuit capacitors, they all look fine. So I guess we are stuck with 100 other possibilities. Let's plug it in and measure the output voltage. There is nothing. Is there a burn mark on this? Always disconnect power before touching a circuit. Always make sure the circuit's high voltage capacitors are discharged before touching the circuit. Just weld it. Okay, so there are a few input filter components, the rectifier and its capacitor. Let's measure the voltages. Around 115 volt AC input, around 160 volt rectified DC. So all seems good there. Must be the controller circuit. They are using OB2269. I found the datasheet of the chip. Why does it even say confidential if it is available to public? So this control chip, powered by the rectified voltage, provides a PWM signal to this MOSFET that switches the primary of this transformer, creating a smaller output voltage here that is rectified into DC. The output voltage is sensed through an optocoupler back to the chip so it can tune the PWM duty cycle to fine-tune the output voltage. For some reason the supply voltage to the chip is 0. I wonder. Ah, look, the chip supply line is shorted to ground, which means the control chip is broken. It didn't die a natural bulging death, you know. This was my raising desk's power adapter and died while I was swinging my high voltage magic wand around. Some good size arcs jump from this thing, eh? Zap you! Zap you! Oh, apparently I killed electronics in my adjustable table. No problem. Replacing this chip is no problem for me. We just need to find the replacement. It's nowhere to be found except Amazon, where I can get 10 pieces for $11 and receive it after a month. I just need one of them though. Maybe I should get 100 pieces for $22 and throw 99 of them into garbage. But that single one will be 22 cents. A brand new wall adapter there is like $20. So I save $9 if I just replace the part, waiting for a month, spending my own time. It's just sad that all these perfectly good components have to go into the garbage. Well, not for me. I shall keep this in a bin of potentially useful parts, potentially never use it, so after my decease, my descendants would have to deal with the horde of garbage I shall collect over years and send me their curses to add kindling to the fire I'm burning in. Thank you for watching. LED lights are expensive, so when they don't last as long as they should, it pisses me off. And that's not all. Look at these! Here I have 20 LED light bulbs, all dead! They are supposed to be for exterior use, but look at this. Some of them are filled with water. How did the water even get in there? If designers knew how to make things to last for a specific application, we wouldn't be in this situation. That's why I picked KiwiCo to sponsor my video, to help teaching kids early to be creative, tinker, and learn with hands-on projects every month. I've got these. I bought 6 of these and 3 of them are already dead. They were supposed to last for 10,000 hours, but all of them died within 6 months or around 600 hours of use. These small ones though, they are part of one of those cheap string lights that go around your garden. They don't have any rating. I bought them from Amazon, so I didn't really expect much from them. But still, LED lights, and they all died within a few months. You think these are not dead and I'm lying to you? Let me turn them on for you. We just need to be careful with loose. How do I turn them on? Oh, I know. I found one of these light sockets with some wire and connected it to my main wire. Let's turn it on. A little bit of electric tape goes a long way. So there we go. Hey, look at this. LED turns on a little bit, so it's half dead. Maybe the LED strings are not dead. How about the small one? The one that's soaking in water. This is definitely dead. Another small one, dead, dead, dead. It seems most of the small ones have a little bit of water in them, and probably that's what killed them. So much for exterior lighting. But these are not some no-name cheap brands. At home I use a couple of different brands and none of them have died except for this one. Except, just to be fair, only these ones are 40 watt equivalent. The rest are 60 or 100 watt equivalent. And you would expect the 40 watt to last longer, but no. Now what do I do with these? I spend a ton of money buying these and I can't even return them after all this time. Can I return them? 3-year warranty? 5-year warranty? And these ones have 10 years warranty? I didn't know that. So I can replace them for free, no? Then I can't really be mad at them. Although it's an inconvenience to go and exchange it for a new one. But hey. So please don't be discouraged from using LED lights. Just go with brands that give you warranty so you can replace them. Unlike the cheap, no-name Amazon stuff that goes straight into the garbage. And learn how to use the warranty too. I don't know how that works. But in any case, it is worth it to pay a little bit extra money to get a good quality light that lasts long and saves a ton of energy. Keep telling yourself, these lights use 1/10 of the power the incandescent lights use. Anyway, to me, it sounds like a design issue. Let's see if we can figure out what's wrong with this so manufacturers can improve their quality. Now, how do we get in there? Let me use my trusty battery. Glass everywhere. Should have put it in a plastic bag. You see, this LED light has only 2 strings in series, and whatever drives them is in this tiny light screw thing. Let's cut the light screw thing open and see what's inside. Look at the tiny circuit. I thought there would be some switching going on, but there is no inductor. Let's see if I can figure out what's going on here. Well, this is an interesting tiny circuit. Basically, the AC first goes into a full bridge rectifier, gets rectified, and powers a chip and the LEDs. This chip is an obsolete Chinese chip with Chinese datasheet, but from what I understand, it's basically a current regulator that limits the current through the LEDs using an external resistor to 30. Kind yet too dumb. What are they doing? Oh, a pigeon is stuck on the power line and he's trying to free the pigeon from the power. Oh, I hope that wood is not conductive. oh my god. That was quite dumb. Oh, just leave the pigeon there, man. You don't need to die for a pigeon. No, thankfully the guy is just shaken. Never touch high voltage power lines, even with a stick. Not only you can kill yourself, you can actually electrocute the poor pigeon too. Maybe just get a basketball and throw it at the pigeon. Much safer. Never assume whatever stick you have is rated for high voltage. High voltage will find any imperfections or moisture and finds its way to your heart. Everyone is safe and healthy here, YouTube. Everyone knows how to find the circuit breaker for a specific outlet. No, you might decide to cut the end of a power cord, plug that in first, and then short out. Stop it! It should be done at safe current levels. A toaster or a hairdryer, plug them in together and turn them on at their maximum settings, and it should pop. What if we inject a high frequency into the outlet, then all the wires will be radiating that signal and we can measure it. Like this, we have a 1 megahertz signal from my function generator we can easily inject into the power line. There are these circuit breaker finder devices out there already. Okay, I bought this 2-piece device. This side injects a signal into the power line, and on this side, this thing has a sensor that you can scan the breakers with. Sounds like a metal detector. Oh, there you go. And it finds the right breaker. Everyone knows how to find the circuit. Can somebody prove this bastard wrong who made a so-called 5-watt current kills not voltage? This 12-volt battery can deliver tens of amps of current if I short its output with this piece of wire. Ow! But it won't deliver through your body because the voltage is too low.
Leute, Achtung jetzt.
I guess don't eat the battery. Current kills not. Electrostatic discharge, or ESD, is an electrical charge that is stored in something like human body and can jump to devices like laptops and cell phones and damage them. What they use for testing is something called an ESD simulator or a gun. Here is a 25 kilovolt discharge. The tip of the gun here simulates a human finger. Always be careful. I'm living with a broken GFCI outlet. What shame! See, it pops open. Let me see if I can charge my body. Oh, I can feel my hair rising. Ow! Something zapped me right in the ass. I was able to make the oil fly. There is this circuit called a voltage multiplier that's made of some diodes and capacitors. Now if I connect the circuits together, the polar capacitors are no good for reverse voltage. So here I made 3 stages of the circuit. Let's stand back and power it up. Do you hear the crackling noises? The series... Ow! Here's my diodes. Now I have to solder the capacitors. Okay, here we are. I shall shove this inside the PVC pipe stand I made. And this is a pretty nice and round doorknob I found as the end contact, which is pretty good for high voltage purposes. I fill the PVC pipe with canola oil. Ooh, yes. I have 2 small cups. One is connected to earth and the other one I'll connect to my high voltage. Okay, there we go. Wow, look at that! And even without touching, see? Let me see if I can charge my body. Oh, I can feel my hair rising. Ow! Something zapped me right. Here, this is similar to a relay, which is... Is it possible to put metal in a microwave oven? It's a little bit hot, not too awful though. So I guess it's okay to put metal in the microwave. No! Any kind of metal you put in the oven that touches the wall of the oven, that will happen, which is bad. If you put 2 aluminum foils like this close to each other in the oven, it should arc. Oh geez! Let's just put one of them in there and see what happens. Ooh. It's just jumping from the very sharp edges. Let me make a sharp tower and see what happens. When the table turns and the foil goes over an area of high concentrated energy, it could arc. If you accidentally leave metals in your microwave oven, as long as they don't have very sharp edges, there shouldn't be any arcing and they just warm up like food. It's very hard to make an arc in a microwave oven. It's easy if you know how to make it. You just need a... There you go. Whoa. Now we can safely plug it in with no problem. Ow! Well, damn it. Well... Plug it in and put it in the... What's buried? Oh no, my wires! Can just plug it under this. Oh, do not attempt this at home, you dummies. There you go. Whoa. Now we can safely plug it in with no problem. Ow! If you have a hard time picking a lock, you can melt the out of it. I'm going to take my microwave oven transformer and get thousands of amps of current. Pull the transformer secondary out. Now let's just turn it on. How does it work without the top on? Oh my God. Let's see how many million amps we'll get shorting our single turn. 90 amps. I did 2 turns now. 160, 140, it's dropping. Oh my God. I went and bought the thickest wire available. Let's see if we can melt some spoon. Okay, the key is not to be afraid of the sparks. They're just some low voltage, high current sparks. My spoon absolutely melted. Oh my God. If you have a hard time picking a lock, you can melt the out of it. What would happen? One charger plugged into another? Let me try it. Here's an old 5-volt USB charger, and this one has a USB-C charger. Let's plug it in. Nothing happens because they both stay at... Let me see.